Hello, I'm Mrs. J and welcome to my math class. Today we're going to work with some story problems with integrals. And these ones are find the cost function for each marginal cost function. And the first one the marginal cost is this. Remember, marginal cost was the derivative, and the fixed cost is $8. What fixed cost means is when your cost function is 0, when x is 0, the function is 8. Because fixed cost is your constant. Well, not always your constant. In the polynomials it is. So the first thing we need to do is find c of x by taking the integral. So when I take the integral, remember you add 1 and divide by that value. So it would be 4x squared over 2 minus 5x plus c. 4 over 2 can reduce, and that equals c of x. Now this was given to us so we could find c. It means when x is 0, the function equals 8. So that means that 8 equals 2 times 0 squared minus 5 times 0 plus c. These drop out. C is 8. So our function is 2x squared minus 5x plus 8. Try another one. C prime of x equals 300ths e to the 0.01x, and our fixed cost again is 8. First, take the integral to find c of x. When we take the integral, exponential stays the same. But then we divide by the derivative of the exponent, which is 0.01, plus our constant. And if we divide these, we get 3. Now we need to plug in and find our value. I'm going to plug in over here so there's more room. So cost is 8 when x is 0. Anything to the 0 power is 1, so this is just 3 times 1, or 3. Subtract the 3. So c is 5. Try one more. So our marginal cost is x to the 2/3 plus 2. And instead of giving us fixed cost, they said 8 units cost $58. First thing, take the integral. So we add 1. X to the 5/3 plus 2x plus c. And when we add the 1, don't forget to divide by it. This would be 2x to the first, so dividing by 1 doesn't change it. Now when you divide by a fraction, you can flip it and multiply, so this is actually 3x to the 5/3 over 5. Then we're going to plug in to find the value. It says when there's 8 units, the cost is 58. So 58 equals 3 times 8 to the 5/3 over 5 plus 2 times 8 plus C. So we can calculate all of this. When you calculate all of this, you should get 35.2. And then subtract by the 35.2. So C is 22.8. We have 3x to the 5/3 over 5 plus 2x plus 22.8. Now, if you need the fraction, you just hit math, because once you have your decimal, you can hit math and enter twice, and it will give you the fraction. So it could be 114 over 5. Yeah. So text messaging, the next question. I don't know if you can read it though. I'll just read it. Text messaging, the approximate rate of change in the number in billions of monthly text messages is given by this is supposed to be 16. Where T represents the number of years since 2000. And the function is in billions of monthly text messages. Years since 2000, which means 2005, T would be 5. And in 2005, there were 9.8 billion monthly texts. This is giving us information to find C. Find the function that gives the total number of monthly text messages. That means we want to find f of t, and that would be the integral 7.5t minus 16.8 with respect to t. Remember, we're adding 1 and dividing, so 7.5 t squared over 2 minus 16.8t plus our constant. That would be the integral. And then we need to find C. Well, T is years since 2000. T would be 5. So when T is 5, our function is 9.8 billion monthly texts. Now it's in billions, so you're only putting 9.8 in. There we go. And we want to calculate this. .5 times 25 divided by 2 minus 16.8 times 5. Subtract this to the other side, and C equals this. I'm going to take the 7.5 and divide it by 2 and get 3.75. Minus 16.8t plus. Now this one you wouldn't write as fraction because everything's in decimals anyways. So that would be our function, which was part A. Part B says, according to this function, how many monthly text messages were there in 2009? So that means we subtract the 2000. We want T to be 9. We just plug in 9. And I get 152.6 billion. And actually, in 2009, it says there was 152.7 billion. So it's pretty close. Let's try one more. Okay, so it gives us this, and it says, find the demand function for each marginal revenue function. Recall that if no items are sold, the revenue is 0. So on a test, I would make you find the revenue function and the price. Kind of working the other problems that we've done backwards. So first, to find revenue, we take the integral. And you take the integral, 175x minus 0.02x squared minus 0.03x cubed. Now what you want to remember is once you add that 1, you need to divide it. So we added 1 here, divide by 2. Add 1, divide by 3, plus our constant. Going to simplify it. Now to find C, we know that if we don't sell anything, our revenue is 0. So we know R of 0 is 0. And when you have a polynomial, and this is the case, then your C is going to be 0, but it's not always the case. But in this case, C is 0. So our revenue is 175x minus 0.01x squared minus 0.01x cubed. This is cubed. If you remember when we found demand, when we had demand or the price, we took price times quantity, which was either our X or our Q. We need to pull that Q out to find the demand. So you just pull out an X or divide it all by X. Because we need to take the X back out. So if I take an X from each one, it lowers them all by 1 degree. So this would be our demand price.